Internal combustion engines. Faculty, Aussaxena. Index Unit 1 Unit 2 Unit 3 Unit 4 Unit 5 Introduction to I.C engines. Fuels. Unit 2. SI engines. Unit 3. C engines. Unit 4. Engine cooling. Lubrication. Supercharging. Testing and performance. Unit 5. Compressors. Unit 4. Chapter 4B. Lubrication. Prerequisites of engine lubrication. Friction. In engine, frictional losses are mainly due to sliding as well as rotating parts. Engine friction is expressed in terms of frictional power, FP. FP equals IP-BP. A good engine shall limit the total frictional losses below 30%. To reduce friction, an engineer shall do something. Friction inside an IC engine. Friction inside an engine is in the following forms: direct frictional losses, pumping losses, power loss to drive components to charge and scavenge, power loss to drive other auxiliary components. Direct frictional losses. The power absorbed in an engine due to the relative motion of different bearing surfaces such as piston rings, main bearings, camshaft bearings, etc. Direct frictional losses attribute to a higher value in reciprocating engines due to a large number of moving parts, pumping loss. The net power spent by the engine, piston, on the working medium, gases, during intake and exhaust strokes is known as pumping loss. For two-stroke engines it is negligible since the incoming fresh mixture is used to scavenge the exhaust gases. Power loss to drive components to charge and scavenge. In certain type of four-stroke engines the intake charge is supplied at a higher pressure than the naturally aspirated engines. For this purpose a compressor or turbine is used. The devices used, turbine or compressor, take away a part of the engine output considered as negative frictional loss, power loss to drive the auxiliaries. In an engine the accessories like water pump, lubricating oil pump, fuel pump, cooling fan, etc. takes a good percentage of generated power output. This is considered a loss since the power used to drive these components reduces the net output of the engine. Factors affecting friction in IC engines. Engine design. The design parameters affecting friction losses are: stroke bore ratio. Lower stroke bore ratio reduces friction due to less frictional area. Engine size. Larger engines have more frictional surfaces, hence larger friction. Piston rings. Reducing the number of piston rings results in reduction of contact surface from cylinder walls and hence reduces friction. Factors affecting friction in IC engines. Engine speed. Friction increases rapidly with increasing speed, and at higher speeds mechanical efficiency starts deteriorating considerably. Engine load. Increasing the load increases the maximum pressure in the cylinder, hence increase in friction values. Oil viscosity. Viscosity is directly proportional to friction loss. Increase in viscosity, increase in friction; decrease in viscosity, decrease in friction. Factors affecting friction in IC engines. Cooling water temperature. Rise in cooling water temperature slightly reduces engine friction by reducing oil viscosity, but to a limit only. Why do we need lubrication? To reduce the friction and wear of parts subjected to relative motion, leading to reduction of energy loss and increase the life of the engine. Lubrication. Introduction of a substance, lubricants such as oil, grease, etc., between the contact surfaces of moving parts is known as lubrication. And obviously it serves some purposes. What purpose does the lubrication system serve? Lubricate. Reduces friction by creating a thin film, clearance, between moving parts, bearings and journals. What purpose does the lubrication system serve? Sealing. The oil helps form a gas-tight seal between piston rings and cylinder walls, Reduces blow-by. What purpose does the lubrication system serves? Cleans. As it circulates through the engine, the oil picks up metal particles and carbon, and brings them back down to the pan. What purpose does the lubrication system serves? Cools. Picks up heat when moving through the engine and then drops into the cooler oil pan, giving up some of this heat. What purpose does the lubrication system serves? Absorbs shock. When heavy loads are imposed on the bearings, the oil helps to cushion the load. Absorbs contaminants. The additives in oil helps in absorbing the contaminants that enter the lubrication system. Theory of lubrication. Consider two solid blocks in contact with each other. In order to move the upper block over the surface of the lower block, a constant tangential force must be applied. The force due to the weight of the upper block acting perpendicular to the surface is called the normal force. The ratio of the tangential force to the normal force is known as the dynamic coefficient of friction, or the coefficient of friction, F. Theory of lubrication. Theory of lubrication. To keep the block in motion, a constant tangential force is required to overcome the frictional resistance between the two surfaces. This frictional resistance rises because the moving surfaces are rough, and hence small irregularities will fit together at the contact area, interface, to give a mechanical lock to the motion. Theory of lubrication. The resistance between moving surfaces can be reduced by the introduction of a small film of lubricants between the moving surfaces so that the two surfaces are not in physical contact. The lubricant film layer provides lesser resistance than that of the solid surface, and hence less force is required to accomplish a relative motion. The friction due to surface irregularities is also reduced. The solid friction is replaced with a definitely lesser fluid friction. Theory of lubrication. Consider two parallel plates filled with viscous oil in between them, of which one is stationary and other is in motion with a constant velocity as shown in figure. U. V equals U. V equals 0. Theory of lubrication. Let us imagine the film is composed of a series of horizontal layers and the force, F, causing layers to deform or slide over another, just like a deck of cards. U. V equals U. V equals 0. Theory of lubrication. The first layer clinging to the moving surface will move with the plate because of the adhesive force between the plate and the oil layer, while the next layer is moving by at a slower pace. U. V equals U. V equals 0. Theory of lubrication. The subsequent layers below keep moving at gradually reducing velocities. U. V equals U. V equals 0. Theory of lubrication. The layer clinging to the surface of the stationary plate will have zero velocity. U. V equals U. V equals 0. Theory of lubrication. The reason is that each layer of the oil is subjected to a shearing stress, and the force required to overcome this stress is the fluid friction. Hence the velocity profile across the oil film varies from 0 at the stationary surface to the velocity of the plate at the moving surface. V equals U. V equals 0. Theory of lubrication. The fluid or internal friction arose because of the resistance of the lubricant to shearing stress. A measure of the resistance to shear, a property called dynamic viscosity or coefficient of viscosity. Types of lubrication. Considering the nature of motion between moving or sliding surfaces, there are different types of mechanisms by which the lubrication is done. Hydrodynamic lubrication or thick film lubrication. Hydrostatic lubrication. Boundary lubrication or thin film lubrication. Extreme pressure lubrication. Hydrodynamic lubrication. Hydrodynamic lubrication is said to exist when the moving surfaces are separated by the pressure of a continuous unbroken film or layer of lubrication. In this type of lubrication, the load is taken completely by the oil film. Hydrodynamic lubrication. The basis of hydrodynamic lubrication is the formation of an oil wedge. When the journal rotates, it creates an oil taper or wedge between the two surfaces, and the pressure buildup with the oil film supports the load. Hydrodynamic lubrication. Hydrodynamic lubrication. Hydrostatic lubrication. Hydrostatic lubrication is essentially a form of hydrodynamic lubrication in which the metal surfaces are separated by a complete film of oil, but instead of being self-generated, the separating pressure is supplied by an external oil pump. Hydrostatic lubrication. Boundary lubrication. Boundary lubrication exists when the operating conditions are such that it is not possible to establish a full fluid condition, particularly at low relative speeds between the moving or sliding surfaces. The oil film thickness may be reduced to such a degree that metal-to-metal contact occurs between the moving surfaces. The oil film thickness is so small that oiliness becomes predominant for boundary lubrication. Boundary lubrication happens when a shaft starts moving from rest. The speed is very low. The load is very high. Viscosity of the lubricant is too low. Extreme pressure lubrication. When the moving or sliding surfaces are under very high pressure and speed, a high local temperature is attained. Under such condition, liquid lubricant fails to stick to the moving parts and may decompose and even vaporize. To meet this extreme pressure condition, special additives are added to the minerals oils. These are called extreme pressure lubrication. Extreme pressure lubrication. These additives form on the metal surfaces more durable films capable of withstanding high load and high temperature. Additives are organic compounds like chlorine, as in chlorinated esters, sulfur, as in sulfurized oils, and phosphorus, as in trichiral phosphate. Crankcase ventilation. Before knowing about crankcase ventilation, it is important to know about blowby. Blowby. During the compression and expansion strokes, the gas inside the cylinder gets past the piston rings and enters the crankcase, which is called the blowby. Crankcase ventilation. It contains water vapor and sulfuric acid. If either the oil or the fuel contains appreciable amount of sulfur, which might cause corrosion of steel parts in the crankcase. When the amount of water vapor condensed becomes considerable, in cold weather this may freeze and may cause considerable damage to the lubricating oil pump. Hence blowby shall be removed from the crankcase.